Hi everyone and welcome. Today we'll be showing you a few features we developed to be combined together as an automatic parking lot and car detection system. So the first aspect I'll show you now is counting cars and detecting moving objects. The goal of this notebook is to show a proof of concept of the ability to count the number of cars going in or out of a parking lot and therefore being able to track the capacity of cars inside the lot and to also better manage the whole automatic parking lot system. Going over the notebook quickly, we can see that the steps are checking the difference between two consecutive frames. But since it's not a very good result, we also need to set the threshold on the movement to filter the more crucial movement in the video, and also to perform dilation to see the best areas more clearly. We also set an area in the video, which is like the area that we want to check. And we also draw contours using the CV2 find contours function on every object that will be moving around this area, such that if a car is going this way, we can count that one car left the parking lot. We do all the code here, and then we make the frames a video again, and the result is as follows. This is the area, and every car that is moving next to this bar is counted, and therefore we can see how many cars went in or out the parking lot. This one, for example, now it will be 1, and that's it.
Okay, in this section we have two notebooks. The first one is our classification. We have cut the free and occupied parking lot spaces images and trained our model on it. We have been using Chaos module to create our CNN model. We have added a two-convolution max pooling and dropout layers. We have run it with Adam Optimizer, binary cross-entropy loss function, and added a validation set in order to verify that there is no under or overfitting. Here we can see that the train and the test set curves behave the same, which imply us that there is no under or overfitting accurate. We will save the model and use it on the main notebook. For the main notebook, we took that frame and labeled each parking lot space using label image tool, which create an XML file that contains the parking lot axis and the labels. After we passed it, that's how it looks like. It contains two approaches. In the first approach, we have created an image that demonstrates the given parking lot as an empty one, and in each step, we are comparing the specific parking lot space to the empty one. The second approach is to create a median-free parking lot patch to compare each parking lot in each frame to that one. We also examine different approaches for the comparison between patches, including mean squared error, histogram comparison, correlations, and sequence matcher. In addition, we examine our classification model, which take patch as an input and predict if it's free or occupied. To analyze the results, we have been using the metrics accuracy, precision, recall, and F1 scores, which get in a list of predicted and actual labels and produce the scores. We also calculated the running time of each approach. In the main function, we were running each comparison method on each parking lot space for both approaches, saving the results as a dictionary and plotting each predicted parking lot space on the original frame, while the green rectangle represents an occupied parking lot space and the red one for the free. After that, we have created a pandas data frame from the results dictionary and sorted the results by each comparison metric. We can see that the variation change detection method produced better results in most of the metrics and was with the lowest running time. But there are additional approaches that also got very good results, as our classification model and the ABS diff. In addition, we can see that our two approaches got quite similar results. Finally, we will create a demo video from the winner approach. We can see that the parking lot spaces become green when some cars go out, and the green rectangle removed when some car enters to the specific parking lot space.
In this notebook, we are doing classification of parking spots again, but as opposed to the manual setup for the spots as in the previous notebook, we're doing it with code. We use the Kenny edge detection algorithm that we learned in class during the pre-process of the frames and filter out the noise. Then we use the half-lines method for the detection of straight lines in an image, and we use it here. We add some calculations according to the parking spot size, and eventually we get this here. Now we run the classification model that we trained on the images, similar to the previous notebook. We build it all into a video, and we get something like this.